vertical tails, providing stability at all angles of attack. CMM inspection verifies every dimension. Zero tolerance for error.
Heat treatment optimizes strength, hardness, and fatigue resistance.
Sukhoi Su-27 flanker. Russia's legendary air superiority fighter and king of the skies.
The Pugachev's Cobra. Only the Su-27 can achieve this impossible 120-degree angle.
Mach 2.35. Ceiling 19,000 meters. 9G capability.
The following video is a fictional dramatization for entertainment purposes only. Information presented may not be accurate. Viewer discretion is advised.
In 1977, the T-10 prototype took flight, beginning a legend.
Sukhoi Design Bureau. 7 decades of creating the world's finest fighter aircraft.
The production journey spans across Russia, from Moscow to the Far East.
KNAAZ, the Far East's largest aircrate plant and birthplace of the flanker.
Minus 40 degrees Celsius. Russian workers endure extreme conditions to build the flanker.
Over 608 flankers have been produced since 1985.
Every flanker begins with raw materials. Let's follow the complete journey. The Ural Mountains. VSMPO Avisma, the world's largest titanium producer.
Titanium ore, the material that gives the Su-27 its incredible strength-to-weight ratio.
The Kroll process at 1,000 degrees creates 99% pure titanium.
Aerospace-grade titanium ingots, each one destined for flanker composites.
Titanium forging under enormous pressure shapes the flanker's structural skeleton. Russian aerospace aluminum. Special alloys for the Su-27's skin and airframe. Rolling mills produce aluminum sheets that will become the flanker's outer skin.
Rigorous quality testing ensures every material meets Russian military aerospace standards.
GOST certification. Russia's strict state standards for aerospace materials.
Materials travel by rail across Siberia to the Far East factory.
6,000 kilometers from Ural to Komsomolsk. A journey across Russia.
Materials arrive at the factory, ready to become a flanker.
The precision machining facility, where raw metal becomes Su-27 components.
5-axis CNC machines cut complex aerospace shapes with micron-level accuracy.
The wing spar, the primary load-bearing backbone of the Su-27's wing.
Fuselage bulkheads, the structural frames that give flanker its distinctive shape. Landing gear from high-strength steel, built to handle massive touchdown forces.
Aluminum panels stretched into perfect aerodynamic curves for minimum drag.
The titanium canopy frame, protecting pilots at Mach 2 speeds. All moving stabilators, the secret to the Su-27's legendary maneuverability.
The distinctive twin vertical tails, providing stability at all angles of attack.
CMM inspection verifies every dimension. Zero tolerance for error.
Heat treatment optimizes strength, hardness, and fatigue resistance. Surface treatment protects against corrosion in all operating conditions.
Finished components await assembly, each one tracked and serialized.
Next, we travel to Rybinsk to see the heart of the Su-27 being born.
The composite facility, where advanced materials complement traditional metals. Carbon fiber for control surfaces, lighter and stronger than metal. The composite radome, transparent to radar waves, protecting the N001 system. Autoclave curing at high pressure and temperature creates maximum strength. Internal fuel tanks holding nearly 10,000 kilograms of fuel. Wiring harnesses. The nervous system of the flanker with kilometers of cable.
Hydraulic lines rated for 280 bar pressure.
Flight control actuators, enabling the flanker's incredible agility.
The K-36DM ejection seat, one of the world's finest life-saving systems.
The bubble canopy, providing pilots with 360-degree visibility.
Parts kitting organizes components by assembly sequence.
Thousands of aerospace fasteners for each Su-27 airframe. Aerospace sealants, ensuring zero fuel leakage throughout the aircraft. Now to Rybinsk, where the AL-31F heart of the flanker comes to life.
NPO Saturn in Rybinsk, where the AL-31F heart of the Su-27 is born.
The AL-31F, 122 kilonewtons of thrust with afterburner.
Single crystal turbine blades, grown from molten metal with no grain boundaries.
Laser-drilled cooling holes allow blades to survive 1600 degrees Celsius.
Compressor discs from nickel superalloy, spinning at 13,000 RPM.
Fir tree roots lock blades to discs, withstanding enormous centrifugal forces. The annular combustor, where fuel burns at 2000 degrees Celsius.
The afterburner section, adding 50% more thrust when needed.
Variable nozzles optimize thrust at all speeds, from takeoff to supersonic.
Rotor balancing to gram-level precision. Vibration is the enemy.
Engine cases containing enormous pressure and temperature continuously.
Full authority digital engine control, optimizing performance automatically. The accessory gearbox powering all aircraft systems from engine rotation.
Fuel control systems metering exact fuel from idle to full afterburner.
A completed AL-31F. 10,000 parts working in perfect harmony. Every engine undergoes rigorous testing before delivery.
Full afterburner test. 122 kilonewtons of raw thrust.
Test data confirms performance meets all design specifications.
Engines shipped to Komsomolsk, a 4,000-kilometer journey east.
Next, the electronic brain and eyes of the Su-27.
Tikhomirov NIIP near Moscow. Birthplace of the N001 Maech radar.
The N001 Maech radar. Detecting targets beyond 100 kilometers.
Cassegrain antenna, tracking up to 10 targets simultaneously.
Signal processing electronics, the brain behind target detection.
The OLS-27 infrared system. Passive detection without radar emissions. Helmet-mounted sight. Where the pilot looks, missiles lock.
The head-up display projecting flight data in the pilot's line of sight. Flight computers processing thousands of calculations per second. Fly-by-wire control, enabling the Su-27's unstable but agile flight. Inertial navigation, knowing precise position at all times.
Radar warning receiver alerting pilots when targeted by enemy radar.
Electronic countermeasures, jamming enemy radar systems.
Communications linking pilots with ground control and wingmen.
IFF system, distinguishing friend from foe in combat. Complete avionics suite ready for installation in the flanker.
Dual hydraulic systems at 280 bar pressure. High pressure pumps providing instant response to pilot inputs. Control actuators responding to commands in milliseconds.
The GSH-30-1 30mm cannon. 1,500 rounds per minute.
10 hardpoints carrying 8,000 kilograms of weapons.
R-27 medium-range missiles, engaging targets at 70 kilometers.
The R-73 short-range missile, extremely maneuverable in dogfights.
Internal fuel system carrying 9,400 kilograms.
Life support keeping pilots alive at 19,000 meters altitude.
Environmental control, maintaining pilot comfort at all conditions.
Landing gear, supporting 33,000 kilograms at touchdown.
Carbon brakes stopping the flanker from high landing speeds. Brake parachute enabling landing on shorter runways.
Systems integration testing ensures everything works together perfectly.
Everything is ready. Time for final assembly at KNAZ.
The KNA's final assembly hall, where all components become a flanker.
Forward fuselage assembly. A distinctive nose housing the N001 radar.
Center fuselage with blended wing body design, creating lift.
Engine bay for twin AL-31Fs. 245 kilonewtons of power.
Joining fuselage sections with thousandth of a millimeter precision. Thousands of aerospace rivets. Every hole drilled with absolute precision.
Fuel tank sealing. Not a single drop of leakage permitted. Installing kilometers of wiring, connecting every system.
Hydraulic lines installed. The lifeblood of flight control. Avionics installed. The brain of the flanker takes its place. Installing the N001 radar. Eyes that see beyond 100 kilometers.
Cockpit systems where pilot becomes one with the machine. K-36DM ejection seat, saving pilots at any speed and altitude.
Fitting the canopy. Giving pilots complete panoramic visibility.
First AL-31F engine installed. The first heartbeat of this flanker.
Second engine in place. 245 kilonewtons ready.
Connecting fuel, hydraulic, and electrical systems to the engines.
Fuselage complete. Ready for the iconic wings and twin tails.
The Su-27 wing. Large area enabling high alpha maneuverability.
Leading edge extensions generating vortices for the Cobra maneuver.
Wing attachment. The most critical structural joint on the aircraft.
Titanium bolts securing wings. Rated for 9G combat maneuvers.
Wing control surfaces, giving the Su-27 its legendary agility.
All moving stabilators, providing instant pitch control response. Twin vertical tails. The distinctive flanker silhouette emerges.
The tail boom extending between engines. Unmistakably flanker.
Rigging all control surfaces for full travel verification.
Landing gear installed. Supporting 33 tons at touchdown.
The flanker, shape complete. One of aviation's most beautiful fighters.
Su-27 ready for ground testing. Final steps before first flight.
First power on. The Su-27 system's awakening for the first time.
Comprehensive systems checks. Avionics, hydraulics, electrical, fuel.
Hydraulic testing. All control surfaces moving through full travel.
Radar calibration, ensuring accurate target detection and tracking.
First engines in start. Twin AL-31Fs roar to life like thunder.
Afterburner ground test. Blue-orange flames lighting up the Siberian darkness.
Taxi testing ground handling and brake response.
High-speed taxi approaching takeoff velocity for final verification.
Flight clearance signed. This Su-27 is approved for maiden flight.
Maiden flight preparation. The culmination of millions of hours of work.
The test pilot approaches in the cold Siberian morning. History awaits.
Climbing into the cockpit, where man and machine become one.
Systems powering up. The flanker awakens for its first flight. Canopy sealed. Pilot ready. Ground crew ready. All systems go.
Twin AL-31Fs roar to life. 245 kilonewtons standing by. Taxiing to the runway. A historic moment approaches. Afterburners ignite. The flanker rockets down the runway.
Liftoff. A new flanker takes to the skies of the Russian Far East.
Flight testing begins, verifying every performance parameter.
Pugachev's Cobra. The legendary maneuver proves this flanker is perfect. Perfect touchdown. First flight complete. Mission accomplished.
Celebration! A new flanker joins the fleet to defend the skies.
Ready for deliver. From titanium ore to Mach 2.35 Warrior.
From raw metal to legend, the incredible journey of the Su-27 flanker.
Su-27 flanker, defending the skies, writing legends.
The Sukhoi Su-27 flanker, Russia's legendary air superiority fighter and king of the skies.
The Pugachev's Cobra. Only the Su-27 can achieve this impossible 120-degree angle.
Mach 2.35. Ceiling 19,000 meters. 9G capability.
The following video is a fictional dramatization for entertainment purposes only. Information presented may not be accurate. Viewer discretion is advised.
In 1977, the T-10 prototype took flight, beginning a legend.
Sukhoi Design Bureau. 7 decades of creating the world's finest fighter aircraft.
The production journey spans across Russia, from Moscow to the Far East.
KNAAZ, the Far East's largest aircrate plant and birthplace of the flanker.
Minus 40 degrees Celsius. Russian workers endure extreme conditions to build the flanker.
Over 608 flankers have been produced since 1985.
Every flanker begins with raw materials. Let's follow the complete journey. The Ural Mountains, VSMPO Aviation, the world's largest titanium producer.
Titanium ore, the material that gives the Su-27 its incredible strength-to-weight ratio.
The Kroll process at 1,000 degrees creates 99% pure titanium.
Aerospace-grade titanium ingots, each one destined for flanker composites.
Titanium forging under enormous pressure shapes the flanker's structural skeleton. Russian aerospace aluminum. Special alloys for the Su-27's skin and airframe. Rolling mills produce aluminum sheets that will become the flanker's outer skin.
Rigorous quality testing ensures every material meets Russian military aerospace standards.
GOST certification. Russia's strict state standards for aerospace materials.
Materials travel by rail across Siberia to the Far East factory.
6,000 kilometers from Ural to Komsomolsk. A journey across Russia.
Materials arrive at the factory, ready to become a flanker.
The precision machining facility, where raw metal becomes Su-27 components.
5-axis CNC machines cut complex aerospace shapes with micron-level accuracy.
The wing spar, the primary load-bearing backbone of the Su-27's wing.
Fuselage bulkheads, the structural frames that give flanker its distinctive shape. Landing gear from high-strength steel, built to handle massive touchdown forces.
aluminum panels stretched into perfect aerodynamic curves for minimum drag.
The titanium canopy frame, protecting pilots at Mach 2 speeds. All moving stabilators, the secret to the Su-27's legendary maneuverability.
The distinctive twin vertical tails, providing stability at all angles of attack.
CMM inspection verifies every dimension. Zero tolerance for error.
Heat treatment optimizes strength, hardness, and fatigue resistance. Surface treatment protects against corrosion in all operating conditions.
Finished component